this lesson is going to be about parabolas, and the topics are taken from section 10.1 and 10.4, but all of the homework problems, notice they're written right here, are from section 10.4. So our objective is to be able to graph parabolas both with vertical and horizontal axis of symmetry, including, so graphing, the focus, directrix, and we want to be able to write the equation of a parabola given different information, which might include a point, the focus, directrix, and vertex. So we're going to talk about what those things are in case you don't remember from Algebra 2. So, the geometric definition of a parabola is the set of all points equidistant, so same distance, from a point called the focus and a line called the directrix. So if I put a point anywhere on the surface of a parabola, the distance between the focus and perpendicular to the directrix will be the same. So this is the same distance as this, which definitely means that this distance between the focus and the vertex, which is on the parabola, is the same as the distance between the vertex and the directrix. So the directrix is a line and the focus is a point. So this box here at the top is talking about parabolas that have a vertical axis of symmetry. So, you know, if you put a mirror here, it would reflect left, right. So vertical axis of symmetry. And if that parabola is written in vertex form, it would look like this. So notice the x terms are quadratic and the y terms are not. So that's in this case. So again, notice x is quadratic, meaning squared. And the y's are not quadratic, they're linear. So when we're in this case, the parabola opens up or it opens down. We've done these a lot. And in this form, the vertex is h, opposite sign of what you see, k, opposite sign of what you see, and p is going to be important. P, this coefficient right here, if it's positive, the parabola opens up. If it's negative, the parabola opens down. And how do we find the focus and directrix? So notice the focus is inside the curve of the parabola, and the directrix is outside of it, like opposite side of the curve, like away from the way the curve is going. Now they can also face down, and I didn't draw every single case. So if the parabola opens up, the directrix has equation k minus p. Again, that p is important. So this is a horizontal line, so the equation of a horizontal line is always y equals a number. And why is it going to be k minus p? Because the y coordinate of the vertex is k. So the height of this vertex is k. So if I subtract p from k, that brings me down here to the directrix. So that's a distance of p. Now let's talk about the coordinates of the focus. So the focus is the same distance away from the vertex, but the x component in this case is going to be the same. So the x component of the focus is going to be the same as the vertex, which I should have labeled as hk. That's the vertex. So this would be h, because clearly the horizontal component is the same. And then the height is going to be the height of the vertex plus that distance of p. I should have said same. So it would be the k coordinate of the vertex plus p. So that's why that works. Now, notice when p is negative, so that value is negative, many things are the same, but the parabola opens down which means that the directrix is going to be above and the focus is going to be here. So the things that are different are that the directrix is the k coordinate of the vertex plus p because it goes up instead of down, and the focus is going to have the same h coordinate, and then the y coordinate of the focus is going to be k minus p because it's going to move down from the vertex. Okay, so now let's talk about parabolas with a horizontal axis of symmetry. So what's different about this one? So notice that the difference compared to before is that the quadratic term, or the quadratic value, is y. So y is quadratic squared. X is not, X is linear. So that tells you that we're going to open sideways, so we have a horizontal axis of symmetry. So the axis of symmetry, like the mirror, would go here. The vertex is still going to be hk, but notice I moved h and k. So h goes with the x term, and k goes with the y term. And again, they're opposite sign of what you see. So h, opposite sign, k, opposite sign. And if p, same p, is positive, the parabola opens to the right, which is the one I graphed. So the directrix is this equation, focus is that. So let's look over here. So p is the distance between the vertex and the focus, also the same as the distance between the directrix and the vertex, perpendicular. And how do we find these other values? So the vertex is hk, and since the focus is a horizontal distance of p away, the h coordinate is going to change by adding p, and the k coordinate is going to stay the same. That's what this says. Sorry, that's what this says. And then directrix. So the directrix is going to be on the other side of the parabola. So it's going to be a vertical line, and it's going to be a distance of p, in this case, to the left of the vertex. So it's always a vertical line when the parabola opens sideways. So it's going to be x equals. Well, what is x going to equal? So the vertex has the x coordinate h, and we're going to move to the left a distance of p, so that would be h minus p. So that's the equation of the directrix. Now, if p is negative, many things are the same. I should say left. I'll have to fix it. The parabola opens to the left. So what does that look like? So if the parabola opens to the left, you have a focus inside the curve of the parabola, and you have the directrix outside of the parabola. So this would be the vertex. So the vertex is still hk. The parabola opens the other way. The directrix is going to move to the right from the vertex. So the directrix is an equation x equals, and it's going to take the h coordinate of the vertex and move it to the right, so add p to move it over here. So that's this equation. And the focus, the y coordinate is going to be the same as the vertex k because it's the same height as the vertex. And the x coordinate is going to move to the left from the vertex, so it's going to take h and it's going to subtract p because that distance is the same. So let's do a couple of examples. So here we have an equation, and we want to determine the vertex, focus, directrix, and graph of the parabola, including all of those things on the graph. So this is not in vertex form. So what we want to do is complete the square on the quadratic side. So the y's are quadratic. And we want to have the side with the other variables, so x in this case, factored so that inside one of the factors there's an x and no coefficient on it. So I need to complete the square on the left. So I would take b over 2 squared, and that's what I add. So negative 4 divided by 2 squared, so that's 4. So I'm going to add 4 to both sides. This is how you complete the square. So then I have y squared minus 4y plus 4 equals 8x minus 24. And then I rewrite this as a perfect square, which is what we set it up to be. So it's y minus 2 squared. I'm going to factor out the 8, so that's x minus 3. Okay, so this is in the form I want. Now let's determine which way does it open. So y is quadratic. So if you forget, you can flip the paper over. But because y is quadratic, it opens sideways. Or in other words, the line of symmetry is horizontal, so there's going to be a horizontal line of symmetry. So it's going to open this way or this way. Okay. So then we're going to figure out which way it opens by determining p. So p was related to this coefficient here. So 8 is the coefficient, and that was equal to 4p. So p is equal to 2. Okay, that's important. P is positive. So if p is positive, it opens to the right or up, depending on whether it's horizontal or vertical. So it's positive, so it opens to the right. I'm going to just draw a little diagram there. Okay, so it's positive, so it opens to the right. So let's write down the things we know. We know the vertex 3, opposite sign. Notice the x-coordinate is with the x and the y-coordinate's with the y. So 3, 2. So the vertex is 3, 2. I'm going to label it with a V. And then it opens sideways, it opens to the right. So I know the focus is going to be to the right. So let's find the coordinates of the focus. So the x-coordinate is going to move to the right, so it's going to be 3 plus p, which is 2, and the y-coordinate is going to stay the same, so it's going to be 5, 2. So that's the focus. And then the directrix is going to move to the left, and it's a vertical line, so it's going to be x equals, and it's going to move to the left from the x-coordinate of the vertex, so that's going to be 3 minus p, which is 2, so 1, so x equals 1. So right here at x equals 1, this is the directrix. Right, and that's what we were asked to do. So a parabola touches the vertex, and it opens sideways, and you just want to make it look approximately like the distance between here and the distance between there are the same. If I made it too skinny, that wouldn't be the case. So that's a rough estimate of this graph. All right, another example. So now we want to find the equation of a parabola that has this focus and that directrix. You can be given a variety of other information. You just have to use logic to figure out what the missing pieces of information are. So you're going to have questions that are not exactly like this, but you can do it. All right, so I personally am a visual learner, so I like to draw like a super rough diagram of what I know. So I'm going to put the focus in approximately the right place, so 3, 11, just ballpark. So that's the focus, I'll label it with an F. and the directrix is at y equals 3. So y equals 3, so it's horizontal. So y equals 3, that's the directrix. So since I know the focus is above the directrix, I know that my vertex has to be halfway in between. So I plotted it there. I don't necessarily know my coordinates, but I plotted it there. So the focus is 311. Okay. So I know that this distance is the same as this distance, and they're both equal to p. So it'd probably be helpful to figure out what p. Anyway, there's many ways you could figure this out. But notice, from the focus to the directrix, my y values are 11 on the focus and 3 on the directrix. I moved it over just so I had room to write. So how far apart are these? So that distance is 11 minus 3, which is 8. But p is half of that, so p is 8 over 2, so 4. So I know p, first of all, p equals 4, and this is 4, and this is 4. Okay, so I know p is 4. That's important. Also, it's going to be important for my equation. But I need my vertex to be able to put this into my equation as well. So the vertex is definitely going to have the same x-coordinate as the focus. And then the y-coordinate of the vertex is going to be, since I know, well, I could go either way. I could take the y-coordinate of the focus and subtract 4, or I could take the y value of the directrix, I'll do that one, and add 4. You get the same answer either way. So the vertex is at 3, 7. So that's the vertex. Okay, great. So we have the vertex and we have p, and we know that it opens vertically. So when an equation opens vertically, the x's are quadratic. That's important. Okay. And it opens up. Since it opens up, I know that because of my graph here, because the focus is above. P is going to be positive, because I found P just by counting distances, so I really have to think about whether P really should be positive or negative. So it should be positive. So now I'm ready to write my equation. So what does my equation look like? So the x's are going to be quadratic. I'm filling in the stuff that I know, and then I'm going to have 4 times p, which I'll leave open, times y, and then the y value is not going to be squared. Okay, so let's fill in what we know. So p, I'll put p up here. P is 4, and p was positive, and now I just need hk. So the h always goes with the x, so h, k, so h is 3, and k is 7, and again, this one is not squared. Okay, so I'm pretty much done. I'm just going to simplify a little bit. So x minus 3 squared equals 16 times y minus 7. So there it is in vertex form. You can convert it to another form if you wanted to. So you should have all the logic and information to be able to solve the homework problems.